Hybrid search breaks when you average scores that were never comparable. RRF skips score normalization and fuses the rankings instead. This is the pattern you'll be able to implement by the end, which fuses lexical and vector rankings and surfaces one deduplicated order. I'm Professor Pi, teaching search and IR with simple Python. Hybrid search solves a clear problem. Exact matches are precise but brittle. Semantic or dense matches catch paraphrases but can miss keywords. Teams often try to average those raw scores and get results that jump around unpredictably. What we want instead is a single stable ranked list that respects both signals without fragile score scaling. And that's exactly what Rank Fusion gives us. Easy to reason about and light enough to run as a final merge step in a search stack. Reciprocal Rank Fusion, in plain terms, looks at the ranked lists from different retrieval methods and rewards items that appear high in several lists. If a document is near the top, in both the keyword list and the dense list, it wins, even if its raw vector score is lower than a document that only shows up in one view. The upside is robustness. The trade-off is losing fine-grained score magnitudes for the sake of rank consensus. Project Preview. We will build a compact pipeline that does three things. First, compute a lexical baseline by counting matching query terms in each document. Second, build a simple dense view using a TF IDF vectorizer and cosine similarity. Third, fuse those ranked lists with Reciprocal Rank Fusion. Apply a lightweight metadata filter and emit a clean response bundle that includes component scores. The result is a practical, inspectable hybrid ranking you can plug into a downstream consumer. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We will start by building a simple lexical baseline that counts matching terms and ranks documents accordingly. This snippet establishes a lexical baseline by counting how many query terms each document contains. The docs dictionary keeps concise texts keyed by IDs, letting the counter comprehension in doctf capture token frequencies without extra alignment for downstream scoring. The query list holds the lowercase user terms, and lexical sums only those token counts for every ID, so absent words contribute 0, keeping the signal extremely crisp. Lexical top sorts the totals into descending order, so the printed list confirms which documents lead the purely keyword ranking before any dense signals appear downstream. You can tune this by changing tokenization or by weighting rare terms more, but for the demo, the raw occurrence count keeps the signal transparent. That lexical view is useful, but it misses paraphrases and term importance. Next, we'll add a dense similarity that captures shared vocabulary and weighting. This example introduces dense signals by fitting a scikit-learn TFIDF vectorizer and using cosine similarity for ranking confidently. Vect learns the shared vocabulary from the existing docs values, which keeps vector dimensions aligned with our earlier lexical IDs without rebuilding the corpus. Doc matrix stores each document vector. QueryVec transforms the semantic-heavy search string, and cosine similarity compresses their dot products into dense match scores for every ID. Vector scores wraps those floats into an ID-keyed mapping. Vector top preserves the sorted order, and the printed line shows which documents now lead the embedding view with clarity. Adjusting the vectorizer parameters or moving to a true embedding model would change the semantic sensitivity, but not the fusion pattern. Now we have two ranked lists that don't play well averaged together. So instead of averaging scores, we'll merge by rank. This code fuses the lexical and vector rankings with Reciprocal Rank Fusion to produce a single ordering. Rank lists gathers the previously generated sorted IDs, ensuring each retrieval path contributes its entire order, rather than trying to compare incompatible raw scores. The nested loops enumerate every list with a 1-based position, accumulate 1 over k plus pos into fused, and thereby reward documents that appear early across multiple signals. K defaults to 60 here, and shrinking it would exaggerate top positions, while enlarging it would flatten the curve. So the printed fuse top confirms the balanced compromise. This approach is robust to differing score scales and highlights consensus candidates without complex normalization. Fusion gives us a prioritized set, but we still want predictable output and cheap metadata filtering before handing results downstream. This snippet deliberately applies metadata gating and deterministic tiebreaks to stabilize the fused results. Doc tags injects a tiny schema describing which document types we intend to surface, and allowed types captures the current filter the retrieval stack must honor. Filtered walks the previously fused top list and keeps IDs whose metadata matches, so irrelevant candidates disappear before any re-rank or generation stage runs. Sorted with a tuple key that combines fused and lexical makes the order reproducible even on ties, and the printed stable sequence confirms the filtered leader and its score. This step prevents noisy or undesired types from surfacing and gives operators a predictable ordering to rely on. Finally, we need a single consumable payload that exposes every component score for auditing and re-rank decisions. This example materializes the final hybrid response payload, so the downstream caller can consume fused and component scores together. Final bundle iterates over the stable list produced after filtering, preserving the exact ordering chosen by RRF and the deterministic tiebreak. Each tuple captures the rounded fused score, the raw lexical count from snippet 1, and the dense cosine value from snippet 2, keeping every signal inspectable. The printed list demonstrates that the hybrid engine now returns a single deduplicated ranking with transparent feature breakdowns, which is exactly what operators need to trust the merge. You can extend this bundle with source labels or timestamps for more observability. Recap: Reciprocal Rank Fusion merges rankings, not raw scores, so you avoid fragile normalization. Use RRF when you have complementary signals like keyword counts and dense similarity, and you want a robust consensus ranking. One caveat: RRF favors items that appear in multiple lists, so a strong single signal result can get demoted. Next step: tune the fusion parameter K to change how steeply top ranks dominate, or swap TF IDF for a neural embedder to explore semantic reach while keeping the same RRF merge. If short, practical IR helps, subscribe and watch the IR videos.